Hello everyone, and welcome to Earth Archives. Today, we're going to talk about Mars, that mysterious and fascinating red planet. Do you think Mars could really become our second home in the future?
When you think of Mars, do you instantly picture that reddish planet? That's right, it's the mysterious and captivating red planet. Although it seems far away, Mars is actually one of the closest planets to Earth, at times just about 54 million kilometers away. Compared to the distant Jupiter or Pluto, Mars is practically our neighbor, so it's no surprise it's become a hot target for space exploration. Scientists aren't just interested in looking at Mars from afar, they're actively exploring whether humans could one day build bases there or even live long-term. From NASA to SpaceX, and including European and Chinese space programs, many are investing in Mars missions. While Mars has a thin atmosphere made mostly of carbon dioxide, which we can't breathe, it does have water ice, day and night cycles, and even seasons. More importantly, it's not as scorching hot as Venus or as close to the Sun as Mercury, making it one of the few planets in our solar system with potential for being transformed into a livable environment. Behind Mars missions lies more than just technological challenges. They also represent a vision for humanity's future. If Earth's resources are depleted or we face global catastrophes, could we have a backup home? That's exactly why space exploration companies and scientists are working tirelessly to figure out how to transport humans, build habitats, and even grow food on Mars for survival.
Yes, environmental problems on Earth are getting more and more serious, like global warming, desertification, and ocean pollution. That's why we're starting to think, do we need to find a new home? But why Mars specifically? Why not Venus, Jupiter, or some other planet?
That's a great question. Why is Mars such a popular candidate for human space migration? The key lies in its surprising similarity to Earth. First of all, Mars is located near the edge of the Sun's habitable zone, a theoretical sweet spot where, under the right pressure and conditions, water could exist in liquid form. And since water is the foundation of life, its presence means there's hope of finding life and possibly creating a livable environment for humans. Compared to Mars, other planets are far less hospitable. Venus, for example, has an atmosphere like a super high-pressure cooker. Surface temperatures can reach up to 470 degrees Celsius, hot enough to melt lead. Jupiter, while visually stunning, is a gas giant with no solid surface to land on. Mars, on the other hand, is just right. It has day and night cycles, changing seasons, and even a tilted axis similar to Earth's. While the atmosphere is thin and mostly carbon dioxide, with the help of technology, these challenges are not impossible to overcome. In addition, there are signs that liquid water once flowed on Mars, and water ice is still stored at the poles. All of this makes Mars not only a prime target for studying the origins of life, but also a potential site for building human bases. Many space missions, like NASA's Perseverance and Curiosity rovers, are actively exploring the planet's secrets and searching for evidence of past life.
Wow, so how similar is Mars really to Earth?
When people think of Mars, many imagine a cold, alien world. But did you know Mars actually shares quite a few similarities with Earth? Mars' axial tilt is about 25.19 degrees, while Earth's is 23.5 degrees. This means Mars also experiences the 4 seasons: spring, summer, autumn, and winter, although the temperatures are much colder, with winters dropping below minus 100 degrees Celsius. It's not just the seasons that are alike. The length of a day on Mars is surprising too. One full rotation takes about 24 hours and 39 minutes, almost the same as an Earth day. This day-night cycle is a big advantage for future human missions or even settlement on Mars. Imagine arriving on another planet and barely needing to adjust your schedule. That would feel comforting and familiar, right? Even more romantically, Mars has sunrises and sunsets too, but its sunsets are red. That's because Mars' thin atmosphere contains a lot of tiny dust particles, which scatter sunlight into unique shades of orange, red, and blue-gray, making Martian sunsets both familiar and otherworldly. So don't underestimate this red planet. Although it's tens of millions of kilometers away, Mars is astonishingly similar to Earth in many ways. That's exactly why it's one of the hottest targets for human space exploration and potential colonization.
Sounds like a vacation. But is Mars' gravity really much lower than Earth's?
Imagine you weigh 100 kilograms on Earth, but as soon as you step onto Mars, your weight drops to just 38 kilograms. This isn't magic. It's because Mars' gravity is only about 38% of Earth's. For future Martian residents, that light, floating feeling will be part of everyday life. Walking on Mars would feel unusually light, with every step like moonwalking. You'd be able to jump much higher, as if your body became stronger and more agile. Sounds cool, right? But this difference in gravity also brings some hidden challenges. Since the body no longer needs to carry Earth's full weight, bone density and muscle strength tend to decrease over time. Studies show that long-term exposure to low gravity can cause muscle atrophy, bone loss, and even affect the cardiovascular system. So, future Mars bases will definitely need dedicated exercise facilities to help residents maintain their physical health. Treadmills, resistance training machines, artificial gravity chambers. These might all become standard equipment in Martian life. Staying active won't just be about health. It's crucial for adapting to and living long-term on the red planet.
All right, it seems that although Mars has similarities to Earth, its environment is also very harsh. Can you explain in detail what makes Mars' environment so tough?
When we dream about moving to Mars, we often imagine red sand dunes and magnificent sunsets. But don't forget, this planet is no earthly vacation spot. Mars' climate is extremely cold, with an average temperature of only -63 degrees Celsius, much colder than Earth's South Pole. At night, temperatures can plummet to a staggering -125 degrees Celsius, cold enough to crack metal and cause electronic devices to fail, conditions deadly to humans. Such extreme cold means that if humans want to build a base on Mars, the first priority is insulation, comprehensive, around-the-clock insulation. Not only do building materials need to withstand the freezing cold, but powerful heating systems must be installed to maintain a stable indoor temperature. Otherwise, if equipment fails, the people inside could face life-threatening dangers. Similarly, spacesuit design cannot be taken lightly. On Earth, a down jacket keeps us warm, but on Mars, spacesuits need to act like mobile thermal shelters, equipped with heating, insulation, moisture control, and ventilation to ensure astronauts can work safely for extended periods in temperatures as low as -100 degrees Celsius without freezing. These high-tech suits might become everyday wear for future Martian residents. Additionally, the cold could affect energy systems and water management. For example, if water isn't properly stored, it could freeze quickly and damage pipelines. These challenges make colonizing Mars not just a technological issue, but a battle for survival against the cold.
Oh my gosh. What about breathing? Does Mars have air?
Mars might look like a distant relative of Earth, but in reality, its living conditions are completely different, especially when it comes to atmosphere and breathing environment. You might be surprised to learn that Mars' atmosphere is less than 1% as thick as Earth's, and about 95% of it is carbon dioxide, a deadly gas for humans, completely unbreathable. Oxygen? It's almost negligible. This means if you were on Mars and your helmet accidentally cracked or came off, you'd lose consciousness within a minute due to lack of oxygen. This environment makes Mars a true closed life support challenge. On Earth, breathing air is automatic. On Mars, every breath of oxygen must be artificially created by human ingenuity. Therefore, one of the top priorities in designing Mars bases is providing a stable and continuous oxygen supply. Whether working indoors, sleeping, or conducting missions outside in spacesuits, the oxygen systems must operate flawlessly 24/7. This is not just a matter of life support. It's a key factor for the success of any Mars colonization effort. Currently, scientists are developing Mars oxygen production technologies, such as NASA's MOXIE experiment, which extracts oxygen from the Martian atmosphere and may one day be used on a large scale. Until then, oxygen must be transported from Earth or produced on-site through processes like water electrolysis, which demands high levels of energy, technology, and safety measures.
What about water? Is there water to drink on Mars?
On Mars, water is more precious than gold. Although this red planet looks dry and barren, scientists have long discovered vast ice deposits at its poles. Some regions may also have permafrost underground, and even traces of salty liquid water have been detected. These findings give hope for human survival on Mars. As long as there's water, there's a possibility for life and for establishing bases. But the water on Mars is definitely not easy to access liquid springs. These ice reserves are buried underground or trapped in extremely cold areas and require highly specialized equipment to heat, extract, and purify before they can be used for drinking, cleaning, or even growing crops. All of this demands massive energy, support, and stable engineering technology. Future Martian residents will have to become like space farmers, facing the harshest resource challenges every day. They won't just need to find and make water, but also recycle every drop. From shower water to sweat and urine, nothing can be wasted. Everything must be recycled. Every liter of water flowing through the base will affect its entire operation and chances of survival. Moreover, water is a key raw material for producing oxygen and fuel. Through electrolysis, water can be split into hydrogen and oxygen. Hydrogen used to propel spacecraft, and oxygen for breathing. In short, water is the universal resource on Mars. Control the water, and you control the future of survival on the red planet.
That sounds really tough. What about radiation? Is Mars exposed to harmful cosmic rays?
Mars' seemingly peaceful red landscape actually hides an invisible and deadly threat, cosmic radiation. Because it lacks Earth's strong magnetic field and thick atmosphere, Mars has almost no protection. Solar wind and cosmic rays penetrate the thin atmosphere and strike the surface directly. For humans, long-term exposure to this environment means radiation levels far above safety limits, which can cause cell damage, weaken the immune system, and even increase the risk of cancer. This has made building protective shelters one of the core elements of Mars colonization plans. According to current scientific concepts, future Mars bases may not be constructed on the surface as depicted in movies, but rather developed underground, utilizing natural formations such as caves and lava tubes to shield against radiation. Additionally, some studies propose using Martian rocks or soil for 3D printing thick protective walls, which would block radiation while also reducing the cost of transporting building materials from Earth. Another approach involves using inflatable modules covered with radiation shielding layers. After quickly assembling temporary habitats, layers of Martian soil can be piled on top as a natural barrier. Though these technologies might sound far-fetched, NASA and various international space agencies have already been actively testing prototypes and simulating building plans required for long-term missions.
I've heard there are dust storms on Mars. Are they really that scary?
Surviving on Mars means you can't ignore one extreme weather phenomenon: dust storms. These seemingly slow-moving dust storms actually pose huge threats. Martian dust storms can be fierce, with wind speeds reaching up to 100 kilometers per hour, and they can last for days or even weeks. What's even more astonishing is that sometimes these storms spread to become global dust storms, covering the entire planet, turning daytime into darkness, and instantly cutting off visibility and solar power sources. For solar-powered rovers and future bases, this could mean a life-threatening crisis. NASA's Opportunity rover, for instance, lost contact during a prolonged dust storm and was ultimately declared mission complete. This shows that even the most advanced technology can be fragile against Mars' extreme environment. To cope with this threat, future Mars bases will need self-cleaning features, such as vibrating solar panels, automatic dust-repellent coatings, and structures that can retract based on wind speed. The outer layers of the base must also be made of materials resistant to wind and sand erosion to prevent damage from strong winds and fine dust particles. Communication systems will require multiple backup layers and underground wiring to avoid complete disconnection during storms. Furthermore, weather forecasting on Mars will be crucial for survival. Deploying orbiters and ground weather stations to establish real-time prediction systems will allow base residents to prepare in advance and reduce risks. Just like how people on Earth forecast typhoons and tornadoes, future Martians will have to learn how to coexist with dust storms.
It sounds like something out of a sci-fi movie, but scientists are really working hard to explore Mars, right?
Mars exploration has entered a whole new era. One of the most exciting breakthroughs was NASA's Perseverance rover successfully landing on Mars in 2020. This isn't just an ordinary rover. It has been given an ambitious mission to search for evidence of past life on Mars. Perseverance landed in the Jezero crater, an area that may once have been a lake. Through high-resolution photography and geological analysis, scientists found clear signs of sedimentary rock and ancient river channels, indicating that about 3.5 billion years ago, there might have been stable liquid water there. And water is the fundamental requirement for life. Perseverance doesn't just take pictures of the Martian landscape. It actually drills into rocks and soil to collect samples. These samples will be sealed and stored, awaiting future missions to bring them back to Earth for analysis. If organic compounds, microbial fossils, or even signs of past life activities are found, it could completely change our understanding of life in the universe. Besides searching for life, Perseverance is also conducting experiments on the Martian atmosphere, testing the feasibility of converting carbon dioxide into oxygen. This technology is crucial for future human landings and colonization. It means we're one step closer to realizing the dream of colonizing Mars.
Is it really possible for humans to live on Mars? It sounds like a distant dream.
Exploring Mars is full of challenges, but as technology advances, humanity is steadily moving toward this red planet. Mars is about 200 million kilometers away from Earth, and the journey takes several months. This long trip poses huge physical and mental challenges for astronauts. They must overcome psychological obstacles, such as confined spaces, microgravity, and loneliness. After arriving on Mars, the challenges remain severe. Mars' gravity is about 38% of Earth's, and this low-gravity environment can cause bone and muscle loss, threatening human health. Additionally, Mars' atmosphere is extremely thin and mostly carbon dioxide, with almost no oxygen, so breathable air must be provided by life support systems at the base. Mars has extremely low temperatures, averaging around -63 degrees Celsius, and dropping as low as -125 degrees Celsius at night. This harsh cold requires highly advanced insulation technology for the habitat. Even more importantly, Mars lacks Earth's protective magnetic field, exposing astronauts to intense cosmic radiation, so the base must have thick, protective shielding. To live there long-term, a Mars base must be highly self-sufficient. Producing oxygen, purifying air, recycling water, and growing food will all be key technological challenges. Extracting water from the ice layers, generating oxygen through electrolysis, and recycling urine and wastewater through closed-loop systems must all operate precisely to sustain life. Mars agriculture is a new science. Figuring out how to cultivate plants in poor soil and low-pressure conditions will be crucial to securing a reliable food supply.
It sounds really stressful, but also exciting. Are there people who actually want to immigrate to Mars?
Today, human exploration of Mars has entered an unprecedented fast track. Many tech giants and scientific teams are actively pushing the dream of Mars colonization. Companies like SpaceX are developing the reusable Starship, a crewed spacecraft that will be a key tool for carrying the first wave of Mars pioneers. Starship's design not only focuses on reducing launch costs, but also aims to enable multiple round trips between Mars and Earth, truly opening the era of interplanetary migration for humanity. Scientists are also making innovative breakthroughs in utilizing Mars resources. The underground ice on Mars holds precious water, and future pioneers will use advanced technology to extract this ice and convert it into drinking water and agricultural water. Even more exciting, scientific teams have successfully converted up to 95% carbon dioxide in the Martian atmosphere into oxygen through chemical reactions, paving the way for breathable air for humans. These technological breakthroughs will greatly enhance the Mars base's self-sufficiency and reduce dependence on Earth. Beyond resource utilization, ideas for terraforming Mars climate are gradually emerging. Scientists have proposed using greenhouse gases to warm Mars' atmosphere, melting the ice caps to release more water vapor, which would thicken the atmosphere and improve insulation, gradually making Mars' environment more Earth-like and habitable. Although this process may take hundreds or even thousands of years, it symbolizes humanity's long-term planning and boundless imagination for survival beyond Earth.
Wow, so in the future, watching the sunrise on Mars, breathing air we make ourselves, and growing the first Mars plant, this really isn't science fiction anymore.
Exactly. Every Mars exploration mission and every scientific discovery represents a small step for humanity into the cosmos. From the earliest probes sending back blurry images, to today's high-tech rovers drilling into Martian soil and rocks, we are gradually unveiling Mars' mysteries and deepening our understanding of this planet. This isn't just a technological breakthrough. It's a testament to human curiosity and passion for the unknown. However, the journey to Mars won't be smooth. Facing months-long space travel, harsh cold, intense radiation, the thin carbon dioxide atmosphere, and frequent dust storms, building a Mars base is full of challenges. The continuous supply of oxygen, water, and food requires cutting-edge technology and meticulous planning. Adapting the human body to low gravity and maintaining mental health are also urgent issues to solve. Despite all these difficulties, the human spirit of exploration never ceases. Scientists, engineers, and entrepreneurs worldwide keep pushing technological innovations, from reusable rockets and Mars resource utilization to theoretical climate engineering, bringing us closer to calling Mars home. Every successful launch, every instrument functioning properly, and every analyzed data point lays the foundation for future Mars settlement. Mars is no longer a distant sci-fi dream. It's a vital goal for humanity's future expansion.
After hearing all that, I'm totally excited. So, when do you think ordinary people like us will actually get to see a Mars base built?
Mars exploration used to be just a distant dream from science fiction, but now it's gradually becoming reality. Although current Mars programs are still in the stage of decades-long planning and technology development, with continuous breakthroughs and massive investments from global companies, the first group of human astronauts could land on Mars as early as the middle of this century. This historic moment might even come sooner than expected. Landing on Mars isn't something that happens overnight. It involves huge technical challenges and resource coordination. The Martian environment is extremely harsh, low temperatures, low atmospheric pressure, intense radiation, all posing serious threats to human survival. Moreover, ensuring astronauts remain healthy during the long space journey and can establish a self-sufficient living base on Mars are urgent issues to solve. Resource utilization is key. Extracting water and oxygen from Martian soil and developing sustainable energy systems will directly affect the feasibility of future Mars settlement. However, as aerospace companies and research institutions worldwide pour huge investments into R&D, many critical technologies are on the brink of breakthroughs. New propulsion systems, life support technologies, space medicine, and AI-assisted systems are injecting strong momentum into Mars missions. As these innovative technologies mature, humans won't just briefly visit Mars. They'll have the opportunity to live there long-term and operate permanent bases.
Awesome! Today's Mars topic was really fascinating. Mars feels both strange and familiar, full of challenges but also hope. If you enjoy stories about science and space exploration like this, don't forget to subscribe to our channel, hit the like button, and share with your family and friends. Let's explore the unknown world together.
Exactly. Next time, we'll bring you even more mysteries of the universe. Stay curious and let's embark on this interstellar adventure together. Mars might be our next home, but more importantly, it's a symbol inspiring humanity to bravely explore and never stop moving forward.